I know you like the fire, so do I.
So, continuous functions are predictable. But what does that mean? Well, it means two big things. One, no breaks. Well, we already know that breaks occur in functions where no limit exists there. Therefore, for a function to be continuous, it must have a limit at every x in its domain. Secondly, no holes. Continuous functions must be defined everywhere in their domain. Mathematically now, we say that continuous functions have this property. For every x equals c in their domain, the limit as x approaches c of f of x is equal to f of c. In other words, not only does the limit exist at every point, but the height the function reaches for every x matches the limit. How can you tell if this happens? It seems pretty complicated. It's actually easy. If you can evaluate any limit on f of x using only the substitution method, then the function is continuous. And that's all there is to it.
That was a good definition of continuity. Here's another definition of continuity. I say if f of c is defined, the limit of f of x exists, and they're both equal. And that's exactly what it said in the video. A function is continuous on an open interval. It is continuous at every point. Anytime you see a function continuous from negative infinity to infinity, it's called everywhere continuous. Just some jargon for you. We got removable and non-removable discontinuities. Whenever you have a hole, it's removable. Whenever you have a jump, it's not removable. A jump or a infinite discontinuity where they go on forever. So I have some examples here where this one's continuous everywhere. This one, if you do the factoring, you get it. You get an answer. Okay, so that means it's removable, but non-removable, here's one that goes on forever that you can't just plug in the hole and make it continuous. Basically, that's what I'm saying. Limits from the left and the right, we've looked at those. And don't forget the greatest integer function. That exists also. Existence of limits, all right? Remember that a limit exists for it to be continuous. The left and right must be equal, okay? That means the limit exists. That's from the last chapter. And continuity, we've kind of beat like a dead horse here. So that's what we got about continuity. Removable, non-removable, jumps, okay, all those things. And you'll see them in class.